Okay, so we were on number 2 from the back side of the static sheet. And I was just showing you how the x components are going to be equal. So x3x we found, it was 100 newtons. F2x we were about to find. It's the opposite side of the green triangle. So it'll be F2x over 200 newtons. So F2x will equal 200 newtons sine of 30, which of course again is 100 newtons. So they're both 100 newtons, but going in opposite directions, they're just going to cancel each other out. So really what we need are the F2y and the F3y, and they too should be the same. So if we find one of them, let's find F2y. So if we look, it's the adjacent side of this triangle. And so we would do cosine. So cos of 30 will be equal to F2y over 200 newtons. So F2y is equal to 200 newtons cos of 30. Cos of 30 is 0.866 multiplied by 200, 86.6173.2. So F2y is equal to 173.205 newtons going down. F3y is going to be exactly the same thing, okay, because it's also going down. So F3y is also 173.205 newtons. So these two are both going down, and so is the 200. So the net force on the scale will be F1 plus F2y plus F3y. So 173 plus 173 plus 200, F net in the y direction should be, sorry, I forgot to add the 200, 546.41 newtons. Okay, and it's acting downward. All right, number 3. Number 3 is not as hard as it might appear if you draw it carefully. Okay, so for number 3, let's assume we have an XY axis. Okay, so it says 6 forces acting on a central object. Force 1 is 300 newtons acting at an angle of 30 degrees. So this is F1, 300 newtons, and this angle is 30 degrees. The next one is force 2, 200 newtons acting at 60 degrees. So it's not going to be quite as long as the other one. This is F2, and it's 200 newtons, and this angle is 60 degrees. Okay, where'd my orange go? F3 is 500 newtons, 135 degrees, so 90, 135 is going to be in here. And this is F3, and it's 500 newtons. And this whole thing is 135, which means the little part of it there is 45. Okay, now I'm out of colors, so I need to go back to blue, which says force 4 is 300 newtons acting at 210. Well, this line is 180, so 210 is going to be down here. So this is F4. It equals 300 newtons. And this whole thing is 210, which means this one's 30. F5 is 200 newtons acting at 240. So 240 is all the way over here. This is F5. It's 200 newtons. 240, which means this angle is 60 degrees. And then the last one, F6, is 100 newtons acting at 315. So 315 is going to be in here, and it's only 100 newtons. F6 is equal to 100 newtons, and if it's 315, then this angle is 45. Okay, and what is the resultant? If you drew it properly, then hopefully you see these two in blue, they're going to cancel each other out. They're exactly opposite. And hopefully I didn't draw it great here, but these two, they're exactly opposite. They're going to cancel each other out. And these two, they're exactly opposite, but they're not going to cancel each other out because one's 500 and one's 100, excuse me. But you're going to subtract them to get the resultant, 500 minus 100, 400. And so the answer to this is F net is equal to 400 newtons at an angle of 135 degrees. Remember, subtract them and keep the direction of the larger, which is what we just did. Okay, so hopefully, I lost the cap. Hopefully not as bad as you may have originally thought. All right, number 4. Number 4 says, lost the cap again. It's hard to cap all these markers here. Number 4 says, 3 forces are exerted on a central ring. One force is 200 newtons, acting at an angle of 45 degrees. Another one is 100 newtons, acting at 195. And a third one is 100 newtons, acting at 255. So again, draw your XY axis. So the first one is 200 newtons acting at 45 degrees. So this is F1. It's 200 newtons, and this angle is 45 degrees. Now, unfortunately, they are not going to all cancel out prettily like they did last time. So the next one is 100 newtons acting at 195. 195 would be down here. And so this is F2, and it's 100 newtons, and this angle would be 15 degrees. And so it's going to have an F2x and an F2y. Okay? And then the third one is 100 newtons acting at 255. And 255 would be down here. So this is F3, 100 newtons. 255 makes this angle in here. So this would be your F3y. This will be your F3x, and this angle in here will also be 15 degrees. Okay, so you're going to need to find components, just like you're going to need to find components of this guy. This will be F1x and F1y. So you're going to need to find what each of these components are, and then you're going to add up all the y's and add up all the x's. Add or subtract, depending on which way they're going. Okay, so if we start with the green one, the x component is the adjacent side, so it's going to be cosine. Okay, so F2x is going to be cos, so cos of 15 degrees is equal to F2x over 100 newtons. So F2x will equal 100 newtons cos of 15. And when you do that, you should get 96.59. So F2x is equal to 96.59 newtons, and it's going to the left, so I'm going to put an L there. Its y then will be sine, because it's the opposite side. So sine 15 is equal to F2y over 100 newtons. So F2y will equal 100 newtons sine of 15. So F2y will be equal to 25.88 newtons. And which way is it going? It's going down. Okay, so we found the two components for the green one, F2. Now we need to do the same thing for F3. So again, if you look, the x component this time, this is x down here, is the opposite side. So it's not going to be cos, it's going to be sine. I'm going to run out of time. So it'll be sine of 15 is equal to F3x over 100 newtons. So F3x will equal 100 newtons